Hi. In this section, we're going to talk about linear inequalities, not only that, but also absolute value inequalities also. So, mind you, in linear inequalities, we don't have one solution, we have a bunch of solutions. So, if I say a is greater than 0, you know all values of 0 to infinity. Okay? So, let's do this. Suppose 3 minus 2x is less than or equal to 11. And then we want to find x. So you can say minus 2x is less than or equal to 8, right? So if you take away 3 from both sides. Now, if you are dividing it by a negative number, because we have negative 2x, we are going to change the absolute, the inequality. So, you divide this side by negative 2 by negative 2, then x has to equal to what? You have seen this in 1 and 5. Because you're dividing the coefficient of x by a negative number or multiplying it by a negative number, you are going to change the inequality from less than or equal to greater than or equal to. Then you have negative 4, a divided by negative 2. So at this juncture, your solution would be either x is greater than or equal to negative 4, or on interval notation you can write negative 4 all the way up to infinity. Okay. Okay, let me do another one. Minus 2x minus 4 is greater than x plus 5. So before we do anything, just let's combine like terms. Bring x to this side, so you will end up with minus 3x. Bring negative 4 to the other side, it becomes positive 9. Divide both sides by negative 3, then x has to be less than negative 3. So you can write it this way, or you can write this from negative infinity to negative 3, but not including negative 3. Okay? Okay. Suppose we have x plus 3 over 4. Now we have a fraction greater than or equal to x minus 2 over 3 plus 1 over 4. Again, the idea behind it is what? How do we get rid of the denominator? Go ahead, the way we did in linear equations involving rational expressions, find the least common denominator, which is 12. And you go ahead and multiply each term by 12. So what you're going to do would be 12 times x plus 3 over 4 is greater than or equal to 12 times x minus 2 over 3 plus 12 times 1 over 4. Okay. If you do that, then we end up from here, we get 3 times x plus 3 is greater than or equal to 4 times x minus 2 and then plus 3. So now let's go ahead and solve this. 3x plus 9 is greater than or equal to 4x minus 8 plus 3. And let's combine like them. So this one would be 3x plus 9 is greater than or equal to 4x minus 5, right? So move 4x and 3x to this side. So if you do that, so you're doing minus 4x plus 5 minus 4x plus 5. Then you have negative x, right? Plus 14 is greater than or equal to 0. Then negative x is greater than or equal to negative 14. And since you are dividing the coefficient of x, which happens to be negative, by a negative number, then you end up with x is less than or equal to 14. And your answer would be on interval notation, negative infinity to 14 and including 14. Okay? Now, there are some unusual inequalities popping up. So, I'll just give you an example. Look at this one. X is greater than x plus 1. This is an absurdity because whatever value of x you have, this one increases by 1. So this statement doesn't make sense. In fact, just to prove it mathematically, by looking at it, you know that this is not an inequality. So if you take x from both sides, you end up with what? 0 is greater than 1. Then you can prove 0 is greater than 1 doesn't make sense. So this inequality, you would say what? No solution. There is no way that x could be greater than x plus 1. But what if we change the inequality? And this one is what? It doesn't matter what value of x you put, always x is less than x plus 1. So, meaning what? Again, to prove it mathematically, just take this one out. 0 is less than 1 is an absolute truth. So, with this kind of equations, this one would be what? The solution would be all real numbers. You can plug in any value of x you want, or you say from negative infinity to infinity, this inequality is always true for all values of x. Okay. Now, compound inequalities. So, in compound inequalities, it's not that bad. So, let me do x plus 1. Suppose let's solve this compound inequality. Again, it's bounded because we have negative 3 at the beginning and 3 at the end. So let's try to isolate x. So let's take away 1. So if I take 1 from 1, I have to take it from all sides. So you end up with negative 4 is less than 2x and less than or equal to 2. Right? Now, I want to get x by itself, so meaning what? I'm going to divide both sides by 2, so you have negative 2 is less than x, less than or equal to 2. So what this means is, all values of x greater than negative 2 and less than or equal to 2, so you can write this one, negative 2 and 2, and that would be your final solution. I think that takes care of our review of linear inequalities, which you have learned in 095. Now, absolute value inequalities. value inequalities. For this one, I want you to have a refresher, right? So if I say if the absolute value of A is greater than C, then once if I take A out of the absolute value, it means A is greater than C or A is less than negative C. So you need to know this. And if the absolute value of A is less than C, that means A is less than C and A is greater than negative C. This one gives us the intersection of the inequality, and this one gives us the union. One of them goes the other way, the other one goes the other way. But in the absolute value inequalities of less than, both of them come from opposite direction and they converge together. And then you can always check it out. So let me do this. In fact, I'm going to give you one example. The absolute value of x minus 4 is greater than 3. Probably let me start with just 1. Let's say the absolute value of x is greater than 2. So this means what? X is greater than 2 or x is less than negative 2. If you want to write this in interval notation, you know it becomes a union. So this is negative infinity to negative 2. And then there is a gap between negative 2 and 2. So it is a union. And then the next inequality starts at what? At 2 and goes up to infinity. If you do the absolute value of x less than 2, this means x is less than 2 and x is greater than negative 2. This indeed is what? Values of x between negative 2 and 2. You see, the two converge. This one, the two diverge. Okay. So once we set that up, let's do a complicated one. So let's do negative 2, the absolute value of 3x plus 5 plus 7 is greater than or equal to negative 30. We have to be careful. We have to use the order of operation in here. So make sure to move 7 to the other side because this one is multiplication. So minus 7. So you would have negative 2. The absolute value of 3x plus 5 is greater than or equal to negative 20. Right? Now you got to get rid of negative 2. Meaning what? You're dividing both sides by negative 2, negative 2, and negative 2. Mind you, when you multiply or divide by a negative number, the inequality actually flips. So this would be the absolute value of 3x plus 5 is less than or equal to 10. This is what we are going to solve. We started with this absolute value inequality, so we ended up with this. Now, when you take it out of the absolute value, you have 3x plus 5 is less than or equal to 10, and 3x plus 5 is greater than or equal to negative 10. Go ahead, this 3x is less than or equal to, if you move 5 to the other side, it's going to be 5, right? And 3x is greater than or equal to negative 15, right? If 3x is, then x is less than or equal to 5 over 3, right? And x is greater than or equal to negative 5 if you divide both sides. So you end up with what? Between the value of x that you are looking to satisfy this absolute value inequality is between negative 5 and 5 over 3, and in this instance both negative 5 and 5 over 3 are parts of the solution. Probably let me do one which is less than, and I think after that you can be okay. Okay. Suppose you have 18 is less than the absolute value of 6 minus 3x. Okay. And probably it's a good idea to shift it, so you can, this means what? The absolute value of 6 minus 3x is greater than 18. So I'm going to go ahead and do this. Well, I have to take it out of the absolute value, so this would be 6 minus 3x is greater than 18, or 6 minus 3x is less than negative 18. Okay. Take 6 away from both sides, so minus 3x is greater than 12, right? Or minus 3x is less than negative 24. If you take 6 and 6. Now, because you are dividing it by a negative number, negative 3, then x is less than negative 4. Right? And then if you divide this by negative 3 and negative 3, and then x becomes greater than 8. X is less than negative 4, or x is greater than 8. This means what? It is between negative infinity to negative 4 union 8 to infinity. Okay? So that takes care of our linear inequalities.